Hey guys, happy Thursday. Here we are. I think this thing only goes for like 15 minutes, so I'm going to try to keep it fast. The nice thing is if I go fast with my instructions for today, you can just replay the video. Lots to cover today. Things that you're going to notice. You got a Joy video I want you to watch. That's from Mrs. Johannes. You're watching this now. You're going to have a Newsela article assigned to you. Along with that Newsela article, it's really nice. Mrs. Cornell has offered and volunteered that she will read the articles that I assign and do a video of that. So if you want to listen to the article rather than read the article, that's great. Go ahead. Either way, you either have to highlight on the Newsela app what you think key ideas are, or you have to write down somewhere what you think the key ideas are. And then the last thing that we're going to do in this video today is I'm going to talk to you about how I'll be evaluating how you're learning the big key three things that we're going to deal with. Okay, so let me get out of this screen and go to this just so that we can take a look at our results and you can see first and foremost that here's your winner of yesterday's quizzes, and it is Matthew. Sophie's there, Peter, Cohen, London, Ariana, and I'm thinking that's Bella. I'm not sure. Anyway, so Matthew, nice job. You took the cake on that. Okay, the next thing that we're going to talk about, let me go back to this guy, is group meets. So I'm trying to address and do things in a different way, and I set up the small group meets thinking it would be better than having a whole ton of people. But the problem is I sit in front of a computer. If you take a total of 2 small group meet hours per class twice a week, that's 8 hours I sit in front of this computer just waiting for somebody who to chime in. Now, I'm getting some reading done and things like that, but it's still, it's not enough. It's meant to be for discussion and that we can talk about things, and if only 1 or 2 people show up, it's not effective. So we're going to the large group only for science now, so there'll be no small group meets today, Thursday. And that puts us back on a Monday, Wednesday schedule for large group meets. It'll be Monday, Wednesday, 1 o'clock. It's if you want to chime in because you got questions, or if you want to chime in just to say hello, or whatever it is. Whatever reason you have that you want to come in for science between 1 and 2 on Monday and Wednesday. And I'll attach that appointment to our Google Classroom. I do think I'm going to do a special one tomorrow just because I didn't get them today. I didn't do a Monday or a Wednesday this week for the large group. So I'll probably have a large group tomorrow from 1 to 2. You'll see that on the Google Classroom. You can join in if you want. I tell you what, you guys, the expectations that you have are significantly less than what they were when you were at school. So you have 3 big components that we want you to work on that I'll provide feedback as we continue to go for you in science. And you just are expected to work on classes for about 20 to 30 minutes each at home. And then the other expectation is that you show up for things that you're supposed to be on there, like Google Meets. So I'm just pointing out to you, you need to be aware that these are the expectations. They're much less than what they were at school, but there still are expectations. Okay, so Google Meets, I got that. I got a whole list here I'm checking off as I go. I got the Matthew. We celebrated your winning the quizzes. Nice job, 100% first try, very quick. All right, the next thing I want to talk about is your drawing. So your Rube Goldberg machine. You turned in a video of your built Rube Goldberg machine. Awesome job. I had many people, though, tell me that it's really going to be hard for them to round up materials and try to put this thing together. Some have 3 or 4 siblings running around the house, and they've tried to set it up, and as they're trying to set it up, kids are tearing it down before they can even try to make it to work. So what we're going to do is your drawing is really the important part that describes whether or not you understand, how force and motion work inside that machine. So when you do your drawing, initially you pick those 5 words. Those drawings should have the 5 words incorporated. And I don't expect it has to be perfect right now, because as we continue with acceleration, speed, and velocity, and then potential and kinetic energy tomorrow, you'll be able to, this does this every time I do a, hang on. It's a fun game the computer decides to play with me. Anyway, you'll go back and you can add to that drawing or change that drawing. But right now, effectively, if you turned in your drawing of a Rube Goldberg machine with some explanation, which is what the expectation was, you're in good shape. Okay, so we covered that. Next thing I want to talk about is, what is all this about? What's this whole physics unit supposed to even be about? It's not about the basics of force and motion. That's part of it. The overarching biggest idea that you need to understand is that this unit is essentially about energy transfer. And one important thing that you have to understand, so this would be a good time to take out your notes based on forces in motion and acceleration, speed, and velocity. You could add in energy. It can't be created or destroyed. It is only transferred around. Biologically and physically, you take energy that, came to us from the sun, grew plants. We either ate the plants, ate the animals, and then through chemical reactions, we're converting that energy into usable energy in our bodies. And then, of course, when I move my hand or I stand up, sit down, whatever, I'm transferring energy. So this unit, this physics unit, is all about energy transfer between acceleration, velocity, speed, potential kinetic, all sorts of good stuff. So we're just going to keep going through it the best we can. All right, so I want you to keep in mind it's about energy transfer, and you saw that in the slideshow when you looked at that. All right, so I want to go through a couple of things. First, let's do a real quick video lesson, and I'm hoping this works. I'm going to play a video. Now, this is the Six Flags Great America roller coaster in Texas, but they have the same roller coaster in Gurnee Mills, Illinois, just a couple hours from us, and it's my favorite one. It's called Superman. So I'm going to play it with no audio, and I'm hoping that as I move along, we can talk about it a little bit. And then I want you to keep one question in mind for sure, and that is, what the heck is it that makes roller coasters so exciting? I mean, there's the physical part of what it does to your body and your stomach and your brain and I'm trying to think what's the adrenaline and stuff like that. But what is it that at play? What does the roller coaster itself physically do that makes it so exciting? So let me see if I can get this video going, and then we're just going to kind of go through some. So we're going to say goodbye to the results there, and we're going to go over to this. And hopefully this works, guys. So this is the beginning of the Superman roller coaster ride. And if you're looking, you can see that it's, we're taking a turn. So right now, most roller coasters, traditional roller coasters, start out this way. They start out with this, up a hill type of idea. So this roller coaster right now is going in a specific direction at a specific speed. It's not changing direction, and it's not changing speed. So this is a constant velocity. This is a velocity with what's called a vector. So it's a speed with a vector, and vector is just another word for in a direction. All right. So velocity, this is not the most exciting part of the roller coaster. So it's not velocity that makes it. And speed is just a measurement of distance over time. They often reference roller coasters as they go, 40 miles an hour, 50 miles an hour. Some go like 90 miles an hour that are incredibly exciting. So now we see lots of things happening as we ride this virtual roller coaster. One, we're turning to the right, picking up, increase in speed. This is still, even though it's a loop, it's changing direction, right? We're not just talking about north, south, east, west. It can be up, down. So if it's these constant changes in direction and in speed that really make this thing exciting, I want you to tell me, what is it that makes a roller coaster what they are? What is it that brings those sensations to you? Is it speed, is it velocity, or is it acceleration? And then I want you to remember the definitions of those as you did them. Speed is distance over time. Velocity is something moving at a certain speed in a certain direction. And then acceleration is change in speed or change in direction. So which of these three is this roller coaster really doing a lot that really brings you the thrill and the excitement of roller coasters? and this kind of makes me, gets me a little bit. Oh, sorry, lost you there. I'm hoping that when summer comes, we have an opportunity to go ahead and get back on roller coasters and stuff like that. Sorry. Let's hit pause and it went away and came back. Okay. So we covered all these things. Matthews win, the group meets. It's about energy transfer, and that's where we're going to focus. And we could look at that roller coaster. We could really think about the energy transfer. We'll talk tomorrow. What is it that we're building as that roller coaster climbs up, that at that velocity, that constant speed in a certain direction up those hills, and then all of a sudden it starts to begin its thrill ride after that. So what's happening with energy and transfer there? So we're going to shift to make sure we're thinking about energy transfer with everything. Okay. The last thing I want to do in this video, so I can put this notepad over there, is I want to describe to you how I'm going to evaluate what you're doing. And I'm going to be honest with you. Like when I look at things, I look at videos I post. Sometimes on YouTube, it shows like 10 or 12 people watched them. Guess what? I look to see how many watch them. There should be more than that. Really, I should have about 105 kids watching these. I want you to know, how it is I'm going to go through and evaluate. And I only have a few minutes, so I'm going to give you a few examples. Let me go back to this part and click on, here is a sheet that you'll get used to seeing. Okay? I think I can go to view full screen on that. No, it didn't do much. All right. So this is your student, essentially rubric or progress sheet. This will change over the next few weeks, not the sheet itself, but how I score you. So one of your 3 essentials is developing using models. Your other essential, so these are just 3 big concepts you have to focus on, and we're going to focus on these big concepts while we work through the physics force and motion unit. The other one is asking questions and defining problems, and then the third one is constructing explanations. That's your CER business, and we'll probably do some small version of that and then get to a big one. Let's just do the developing using models real quick because that's the one we've been using. If you notice, first of all, there's a link here to the NGSS standard. You don't really need to worry about that. Here's the standard number. You also don't need to worry about that, but this is a form I will share with each of you. It shows you here, I can develop a model that describes how energy is stored and moves in a system. Now, one of those models is your drawing of your Rube Goldberg. That's stored energy that moves and transfers, and the whole reason a Rube Goldberg continues to work the way it does is because of that transfer of energy. Another one is I can develop a model that predicts or describes a phenomenon. Okay, so you have these ideas, and then you'll notice over here you see level of understanding 1 through 4. That's what you need to focus on. What is your level of understanding? Think of it like a video game. If I'm at a level 1, what do I do to get to a level 2? If I'm at a level 2, do I get to a level 3? And you want to be at a level 4 by the end of the year with these physics concepts. So if I'm at a level 1, I'm not sure if it'll let me do this right now, but we'll try. There we go. Let's see if I'm no, I don't need permission. I'm the one that made it. Let me try another one. Interesting. All right, let me go to standby. Running out of time here, but so you're going to watch that level that you're on and which one is which. Okay, I paused it so that I could find the document and not spend 2 minutes. I got about a minute left. So here's the deal. If you look at level 1, so if you had a level 1 on your sheet as I provide feedback, it says that your work was attempted, but it was inaccurate, incomplete, or showed flaws. Now, you'll recognize this too because Mr. Bukowski is using the same scale. If you got a level 2, it was mostly completed, shows a pretty good understanding, but, still not where we want it. 3 is mostly completing, shows a little bit higher level, but you cannot apply the information or skill to a task. So in other words, you build a model of a Rube Goldberg or you draw one, but you don't apply what you understand to it. And then the last one is it's mostly completed, shows a higher level, and shows some depth. And you'll have these provided as well. Okay. So you have the asking questions, defining problems is another one. And then there's developing models. Or, I'm sorry, constructing explanations. That's it for today. I will see you tomorrow, Email me with any questions. See ya.